Now that you have some experience evaluating powers containing rational exponents, we're going to extend our ideas a little bit more and try to simplify expressions involving rational exponents. Let's try a question together. Copy the question down, pause the video, and attempt to simplify this expression before checking back for the answer. On first look at this particular expression, I notice that we have two bases. We have an m base power in the denominator. We also have an m base power in the numerator. We have n base powers in both denominator and numerator as well. So what that shows me or hints to me is that eventually I might want to combine these different powers to create powers that appear more simplified. The other thing I'm noticing here is that we have two exponents, or actually three exponents, that are separated by brackets. So that's the situation where we're dealing with the power of a power. Before I can take any of the powers in the numerator and combine them with powers in the denominator, I'm going to need to deal with this. What we'll remember is that this negative 1/2 exponent, because the mn cubed is in brackets, this exponent applies to both the n cubed term as well as the m term. If I want to write the m as a power, keep in mind that there is an exponent 1 attached to the m. The next thing we will want to remember is that when we're taking the power of a power, we actually multiply the exponents. So my m term will end up having an exponent of 1 times -1/2, which is -1/2. And our n term in our numerator will have an exponent of -3/2. And of course that -3/2 comes from multiplying the 3 times the -1/2. I know that 3 is really 3/1, and when I'm multiplying fractions together, I multiply numerator times numerator and denominators times denominator. Now we have an m power and an n power in both the numerator and denominator, so I'm going to be able to now combine those to create single m powers and another n base power. So when I am dividing two powers with the same base, I recall that I may subtract the exponents to simplify. So for my power with base m, I'm going to have -1/2 subtract 1/2. And for my power of base n, I'm going to have -3/2 subtract -5/2. So let's work that out. For my m exponent, I'm going to have -1/2 minus 1/2, so that's the same thing as -2/2, and of course we can simplify that in a moment. For my exponent attached to my base n, I have -3/2 subtract -5/2. When we are subtracting a negative, we remember that that's the same thing as adding a positive. So I can simplify that, and I'll notice that I will get -3/2 plus 5/2, which is going to give us 2/2. If I simplify the fractional exponents, this will become m to the -1 times n to the 1, which of course I could just write as n. Generally, when I write my final answers, I do not want to have negative exponents, so I'm going to want to rewrite the m power. Keeping in mind what we learned about negative exponents, I know I can rewrite m to the -1 as 1/m to the 1, and of course I've got the n that's multiplied there. If I wanted to, I could write in my n also having a denominator, which is 1 because nothing was written, and then I can simplify, and that can just become n/m. At this point here, where I'm starring, many of us may just realize that if I want to write the equivalent expression I could just write n, keeping it where it is because it had a positive exponent. Since the m power had a negative exponent, simply moving it to the denominator changes that exponent to a positive. So many of us might just do that, but the y of that is listed in detail there in the red bracket. Let's try one last question. Just like before, take a moment to copy the question and think it through before checking back to determine if your answer is correct. So the first thing that I'm going to notice here is that my radicals have different root indices. So I'm not going to be able to take what's inside my radical up here and simply divide it by what's inside the radical in the denominator, because these are different types of radicals. So our best approach with this is to take and rewrite these radicals as powers, and then we can apply our power rules to simplify the expression. So in this step, I've taken and done just that. I've taken the radical sign and rewrote it as a fractional exponent. Something else that I might want to do before proceeding is notice that I've got the power of a power here inside the bracket in the numerator. I notice also that this exponent 2 applies to both the x to the 6th term as well as to the 8 that's inside that bracket. So I think I'm going to manage and deal with that first. We'll recall that the exponent on the 8 is actually 1. So when we take the power of a power, we will multiply those exponents. We can simplify the numerator even further by replacing the 8 squared with 64. Now we're dealing with a similar situation with our fractional exponent. Keep in mind that this 1/6 exponent, this applies to both the x to the 12 term as well as to the 64. So let's go through and multiply that exponent. So we recall that when we are multiplying fractions together, we multiply numerator times numerator, denominator times denominator. We recall again that the denominator in that exponent would be 1, and this would be an exponent of 1 on the 64. Another step that could help me to simplify this more easily is to take my power with the fractional exponent and rewrite it as a radical. Now, something we need to mention here is that I know that we know how to use our calculator to actually evaluate fractional exponents. One of your curriculum expectations is that you do know how to convert it to the radical form. So be sure that you're not just using your calculator, that you're actually showing that step in between. I may be asking you to do that, maybe placing variables here instead, so that it forces you to do that. So just be cognizant of that fact that you need to be able to manage those types of situations. So using our radicals here, we can evaluate the radical in our numerator. We are asking ourselves what number multiplied by itself 6 times gives us 64, and that answer is going to be 2. So we'll have 2x squared in the numerator. In the denominator, to evaluate that radical, we are asking ourselves what number multiplied by itself 4 times gives us 625, and that number is going to be 5. So I'll write down a 5. We have an x squared in our denominator as well. We want to go further and simplify this expression. We notice that we have 2 powers with the same base. We are dividing those powers. When we're dividing 2 powers with the same base, we subtract our exponents. So we'll be left with 2/5 x to the 0. We know that anything equaling with an exponent of 0 is equal to 1. So this is really just 2/5. Notice our thinking could have been slightly different, but getting the same answer. I simply could have noticed that I have the same thing in the numerator and the denominator. When we have something in the numerator that's the same as in the denominator, they divide away and produce 1. We'll get the same answer of 2/5 regardless of what our thinking is.